A more classic example of geometric probability is a little more literal. Here I have some areas to consider. A rectangle 5 by 7, a square 2 by 2, and a triangle with a height of 4 and a base of 3. If you flip it over, you can see 3 is my base, even though it's on the top. 4 is my height. Hits that base at a right angle. Now, I may ask, what's the probability of landing inside the square? So that means I'm saying that I'm going to land somewhere on this overall rectangle, specifically inside the square space. I continue to apply my basic philosophy. The area of what I want, which is 2 by 2, over the total landing area, 5 by 7. Which is the same as saying 4 square units of square over 35 square units of total outcome. Now what I can do is, it's already reduced, I can now calculate it down. 4 divided by 35 puts me at 0.11 or 11%. Probability of what I want inside the squares area, total probability, 35, 11% chance of happening. Move that decimal point over just a little bit, make it more clear. There we go. Now, I may also ask, what is the probability of landing in the triangle and the square? Triangle and square. Now you want to be very careful. When I use the word and, I'm saying what is the probability of both of those things happening at the same time? And in this case, if I look, where on my diagram do I have a point that I might land on if I can fly it in here that is both in the square and in the triangle? Let me pause for a moment on that thought and let's talk about cards for a moment. Earlier, I talked about using some pictures of the family to help illustrate the point. I had 3 pictures of my lovely daughter Kaylee, a picture of my lovely wife, and my handsome son. If I were to talk about the probability of pulling out a picture that is Xander and Kaylee, or the probability of Xander and Kaylee happening, how many pictures in my collection fit that, have both Xander and Kaylee? Well, none do. There's no picture I can pull out that will do both of those. This is not asking for the probability of drawing out a picture of Xander and the probability of drawing out a Kaylee and perhaps adding them, because we're used to and being add when we do arithmetic. In probability, and refers to the possibilities where both are happening at the same time. With the card analogy, I would need a picture that has both of them in it. Since this picture is not in my deck of pictures, it's impossible. Let's go back to what we're working on right now. Where in here do I have points that are both in the triangle and in the square? I don't see any. So this probability is simply 0. It's impossible to land in the triangle and the square at the same time. Be on the lookout for those kinds of problems that may attempt to trick you. The word and in probability does not mean to add. It means to ensure that both conditions are met at the same time.